Okay, everyone, we are going to continue with the lecture in Chapter 9, and I went ahead and created some topics to talk about to give me some guidance as we're going through, so I'm not figuring it out on the go. We've got some topics to go over. So the first one is private methods and stale data. I went ahead and created a new class to demonstrate this. Different from the class we were working with yesterday. So when we have a room class, again, I typically start by marking my classes as public. Not mandatory, but it's common convention to have public classes. So I always make that change there. A typical room, is going to have a length and a width. So if we go ahead and make our fields, which we defined these yesterday as instance fields, and they're private typically. Private a width and a length. And you would think, and you know, we could talk about private methods and stale data here. You would think that you might have a variable for area, and that would store the length times the width. The one thing that we didn't talk about yesterday is that we really, oh, that's nice. We really didn't talk about a third type of method. Yesterday we talked about mutators and we talked about accessors, if you remember that from yesterday. A third type of method, right? Mutators modify data, accessors access data. A third type of method is just a method that does math. Okay, and that's what we're going to use to calculate our area. However, to have an instance field that stores area, that could create this problem of stale data. So I just want you to realize, we're going to get into this, we're going to talk about why we might have a private method, but anytime a method that can do a calculation stores a result, think about this for a minute. Okay, and let's just put some comments here. Here's a scenario. Okay, we set the width to 5. We set the length to 5. We call the area calc area method. Okay, so what happens to the area? If we had this area field, what would the area be? If we call the calc area method, 5 times 5, 25, right? Okay, so following the flow of our program, set the width to 5, set the length to 5, call the calc area method. Now let's do this. Let's set the width to 6. We modified the width. Now let's call the get area method. It's still 25. You see how that creates the problem of stale data. Okay? So to store the results of calculations, well, that calculation is based on some other things. Okay? And where if you aren't seeing the problem, get area method returns 25, but the current width is 6, the current length is 5, the area should return 30. Instead, the area is returning 25, aka stale data. Okay, so I'm going to show you how, by creating maybe a private method, when you set the width and when you set the length, you can also calculate the area, and you don't need to store area anymore, because area has the potential of going stale. Okay, so I'm not going to store area, and I'm going to code the rest of this out. Just like we did yesterday, I'm going to say scenario for stale data. Okay, So I'm going to code this out, and just like we learned yesterday, we're going to make a property. Okay, and this is going to return length, and the set is going to set length equal to value. This is very similar to what we did yesterday. So here's our properties. We'll make another one for width. Now I'm going to make a private method. You see up here, that's the first thing here. The purpose of a private method is to be used repetitively within this class. Not that other classes need access to that. Remember, methods are typically public, but not always public. So if there comes a scenario where you need to reuse a chunk of code multiple times in your class, put it in a method so you don't have to have repetitive code in your program. So what I'm going to do here, I'm going to make a private method. It's going to return a double. And it's going to be called calc area. Now, what this is going to do is it's going to return the current length times the current width. This is returning the fields, the length field times the width field, right? That's returning the current value of this and the current value of this. Now, anytime I set the length, I'm also going to call calc area. I got to think this through for a second because this is returning a value. You know what? This scenario is created this way. If I uncomment out area, we can have our field and then just set area equal to length times width, and then this will return void. Point being, anytime we set the length or we set the width, we're going to calculate the area. So if the width were to change like it did in our scenario, here our width would change, but automatically when the width would change, the area would change. So it would update the area and it wouldn't become stale, because on both scenarios you update the length, you calculate the area, you update the width, you calculate the area. Now we can write a read-only property, so public double area. We don't have a set block, but we do have a get block. Darn it, it's not a method. We do have a get block that returns area. So it returns the field, but the field is calculated when you're setting the width or you're setting the length. The field is not calculated, by, or the field is not received the field is not received by a set block. It is instead calculated inside of a private method. We set the length and the width. So let's demonstrate this inside of our main here. This was all of our stuff from yesterday. I'm going to write one big block here, and let's just demonstrate room is our class called my bedroom equals new room. My bedroom dot width equals 5. Don't forget, when you call these properties, this calls the set block of the width property. And if you go inside there, don't forget that also calls the calc area method. Same thing with length. Okay, so in our scenario, we set the width to 5, we set the length to 5. Let's do the output. Console.WriteLine of my bedroom.area. Remember, if you don't have an equal sign, that calls the get block of the property. So this will be 5 times 5. The output should be 25. Let's go to start without debugging. And we have the correct output. Now, after we do that, let's change the length like we did in our stale data example. Anytime we calculate the length, we also calculate the area. Therefore, after here, if we print out the area again and run it, you should see the area has been properly updated. We don't have the problem of stale data. So I went through that pretty fast. It's been 12 minutes, but we did cover both private methods, remembering that's when you have repetitive code inside of a class. In other words, with this calc area, this line here, area equals length times width, would have had to been here, and it would have been repeated here. Since we had to repeat it, we chunked it out, put it into a method, and created a private method because you don't need to calculate area outside of this class. And then we fixed the problem of stale data by updating the math anytime one of those two fields is set. Okay, so that's the first topic. Any questions on that?
Let me see the main method.
You want to see the main method?
Yeah.
So here we instantiate a room object, right? You create an instance of the room class, therefore creating an object. You call the properties width and length. You then get the area, update the length, get the area again. Okay, next topic. Okay, references the keyword this. And for that, I'm going to open up yesterday's example of person. So if you guys want to get refamiliar with the class of person, we had our fields, we had a couple of properties, but we also had a mutator and we had an accessor. Now, this concept of the keyword this, or the this reference, is easy to explain right here. And remember this, these are our fields. And A down here is our what? A is called what type of variable? Not all at once. This is our field. A is a, starts with a P, parameter. Yes, thank you. So what do we do inside of the method? We set the field equal to the parameter. Now some of you in this class have already said, hey Mr. G, since A represents age, can't we just say age here? Well, if we do that, the code will change to something like that. You even see assignment made to the same variable. Did you mean something else? You're setting the parameter equal to, if you did this, you'd set the parameter equal to the parameter, which clearly is not something you want to do, right? What we want to do is set the field equal to the parameter. Well, that is easily remedied by adding the keyword this. When you add the keyword this to the first, to what you're changing, this again changes, sets the field equal to the parameter. So if I had to summarize, the keyword this refers to the instance field. That's what the keyword this, when you put it in front of a variable, it refers to the instance field. And age without this, meaning this age variable without the keyword this reference, still references the parameter. Still references this. So what's the benefit here? Well, it makes your programs more self-documenting. You want to name your variables accurately, something that describes the data that goes in them. Int A, what is A? A, you know, you might be able to figure it out because you're setting the age, but it's not a self-documenting variable.
Could you just do like age with a capital instead?
Could you just do an age with a capital? Yes. However, that goes against the naming convention. Naming conventions say, hey, my variables start with lowercase. So most companies are going to have a very strict naming convention you have to follow. Okay? And that's what the keyword this does. Anytime you see the keyword this, it's referring to the instance of that object, or the instance of that, in this case, the instance of that field. By the way, this problem right here, without the keyword this is a problem called shadowing. That's what that is. That's the term they call that, shadowing. When the field overshadows, when the parameter overshadows the field. Fixed by adding this dot. Then it's not shadowing. Okay. So let's go back here to our other class. We talked about that. We demonstrated private and stale data. We made our properties here. talked about the this reference completed in the person class. Okay, yeah. Okay, moving on is a few discussions on constructors. To kind of start with the basics here, with what is a constructor. And we can stay inside of this class here, inside of demo room, I should say, inside of class room. Right now we haven't created a constructor. But the first thing to realize about constructor, well, okay, what is a constructor? A constructor is a method with the same name as the class. Okay, so that's a constructor. It's a method with the same name as the class. So if we have a class named room, what's the name of our constructor? Room. But it's a method with the same name as the class. So I'm going to put my constructor right here, right after our instance fields. Okay? And because we know it's a method, we're going to mark it as public. Now, most methods have return data types, right? Void or int or double. A constructor doesn't have data types. That's another thing to know about constructors. Constructor does not have a return data type. Not even void. It just doesn't have one. Okay? But it has the same name as the class. Now, what does a constructor do? What's the purpose of a constructor? Remember, yesterday we talked about these instance fields. The first thing we did was said accessors and mutators. We create methods to modify these fields and to access these fields. And then what did we do? We created properties. And what did properties do? Properties modified these fields and they access these fields. So what does a constructor do? A constructor, many times, a constructor will modify or set the instance fields. Just like a mutator, just like a property can. You're going to set the fields. Now, what I have written here, this is called the default constructor. Notice how it has no arguments, or no parameters. I should say no parameters. Right? There's nothing in our parentheses. As a matter of fact, there's nothing in our curly braces. This default constructor doesn't set any of our fields. And I'll tell you something else. If you don't code the default constructor, the C# compiler will add it to your code for you. And you know how I know this? I can delete this constructor. Let me save and close that. Over here, when I say new room, what does that look like to you? It's a constructor call. You're calling the constructor right here. This is where you're calling the constructor. Now, did you code a constructor? Did I code a constructor before this? No. But does that work? Yes. This calls the default or no parameter constructor. What does a no parameter constructor do? Well, it looks at all your fields and it sets them to you know, 0.0, 0.0, 0.0. The default constructor sets your fields to 0 or null or empty or nothing. Okay, it makes them empty. But what if, let's make a constructor now. I'm going to put this constructor back in. I'm going to make a different constructor actually. I'm going to make a public room, but this one's going to have parameters. It's going to have a width and a double length. And I can say this dot width equals width, this dot length equals length. Because you understand what the keyword this does, we realize setting the fields equal to the parameters, params I'll just say. Setting the fields equal to the parameters, and because I have a calc area method that's private, I can call the calc area as well. Now, what does this do for us? This adds flexibility. Okay? Now first off, also notice this. It's kind of interesting. When I build my own constructor, the default goes away. If you add a parameterized constructor, the default goes away. I'll show you how to fix that in a second. But watch it. If I say room, your bedroom equals new room, and I type in my parentheses, look at what it's expecting. It's expecting a width and a length now. So if I say 8 by 8, I could do a console.writeLine your bedroom dot area your room has an area of your room dot area, right? And if I just run that, debug, start without debugging. Of course, this isn't compiling right now, so I'm going to comment that out. And of course, then these aren't going to compile. So boom, 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 boom. Debug, start with debugging. And there you go, 8 times 8, 64. So another way we set the width, we set the length. Let me go ahead and put a breakpoint in here so you can follow this, right? So if I debug, start debugging, let's step into, notice it goes into the constructor at this point. It sets the field, which is currently 0, equal to the parameter, which has 8. It sets the length field equal to the length parameter. It then calls calc area. Calc area sets the area equal to 8 times 8. So we now have the bedroom created. It says your room has an area of, and then it calls the property to return the value. So you could just kind of follow the flow there. Any questions on this constructor? Now, I did mention something I said I'd come back to. This is no longer the default constructor, right? This is a parameterized that's a tough word to spell, parameterized constructor, meaning it has 2 parameters in the parentheses. Now, when you code one of these, I told you that the default goes away. So the compiler doesn't put the default in there automatically for you. You simply have to code the default if you still need to use it.
I was gonna say, because I left my default in there
And it worked.
One didn't. It just goes into the right
Yeah,
area.
it just goes into the right one. So now I can uncomment out my bedroom, because my bedroom calls the default constructor, and this one calls the parameters, the params constructor. And I can even show you that. Put the breakpoint in, debug, start debugging. Look where this one goes. It goes into the default. This one goes into the other one, the parameterized constructor. And just to have all of our demo back, so we can have my bedroom and your bedroom. So, question for you. What's it called when you have two methods with the same name but a different parameter list? Overloading. So here we have constructors. They are methods. They have the same name but different parameter list. Therefore, we have overloaded constructors, which, if we go back to our original what we're doing today, talked about this, we talk about constructors. We now have also overloaded constructors. The one thing I haven't said that I want you guys to realize, what does this do for us? Just like there's multiple ways, I said this before, there's multiple ways of doing the same thing. We're setting data at different ways. Well, if we need to create an object and we don't know the fields, we can use this no-arg constructor if we don't know any of the data. But if we do know the data, we can construct an object and start passing values into their fields at the same time as the construction, as it's being built. Okay, as it's being put into RAM on your computer. Okay, so in this case, we set the values using properties. In this case, we set the value using the constructor. And so what does that do for us? It's flexibility. Is really what it boils down to. It's flexibility. You write your code so that people can use it in different ways. You know, whichever way works for them.
So like this constructor is kind of like shorthand of what we did right before?
Yes. Yeah, this constructor, you could view that as a quicker way of setting the fields, right? Because this 8 and this 8 get passed into width and length, and then width and length right here gets assigned to the field width and length. This constructor looks a lot like a mutator in ways. It looks similar to a mutator in ways. If you go down to this mutator, oh, we had that in the other class. If you go to this mutator here, where is it at? You know, we have this dot age equal to age, and it takes one parameter. Well, our constructor, this dot width equals width, and it takes a parameter. I can overload our constructor again. Maybe for, you know, maybe it would benefit the person who writes this class, or who, excuse me, uses this class. If I say public room, maybe I only know the width. Right? So now I can construct an object that has a width, but it doesn't have a length. Room just going to say J's room. Oops. Equals new room. And now we see the overloaded calls. We see the no arg constructor. We can press here. We see a constructor that takes a width. We can press here. We can see a constructor that takes a width and a length. So if we're just going to use the one with a width, 10.5, because J's room also needs a length, it's going to be an oddly shaped room. I'll go ahead and copy the output. Actually, I'll just write it again. Console.WriteLine. J's room has an area of J's room dot area. If I run this, J's room has an area of 21. 10.5 times 2. There you go. So it just adds flexibility. I could do it the other way, right? I could have another overloaded constructor. Takes the length, sets, you get the idea? This dot length now this is causing a problem because really the name of the variables doesn't matter. So this wouldn't work actually because this is not a valid way to overload a method. You can't have overloaded methods that just both accept doubles. So we've kind of run our limit on overloading there. We can't do it that way. You have to have another way of doing it. Maybe length becomes a different data type. There's other ways around it, but that's not working. Okay. So let's go ahead and move on. Let's talk about constructor initializers. And as we started writing all these constructors, move up here, you see something here, just even right here, and that's repetitive code. And we try and eliminate repetitive code as best as we can, but we have these different constructors. These different constructors are nice for the flexibility that it adds, but it's not nice because we have repetitive code. Now you can imagine this class is pretty simple. We've got 3 fields. Imagine a class with 15 fields. And then you're going to have all these overloaded constructors, and you're going to have a whole lot more repetitive code. Okay? So again, how do you fix that so that you don't have repetitive code? And the answer when it comes to constructors are constructor initializers. So really what you do, and I'll just do it one time. Okay, I'll do it one time, maybe actually twice. Let's do it twice. You delete the repetitive code. Okay, but what happens is if we call this particular constructor, this constructor will end up executing, will essentially call another constructor. Right? So this constructor will just call the other constructor, and so that we don't have to have the repetitive code. And let me show you how it's done, and it'll make sense as I begin to code it. What this actually would look like is I'll put a colon after this constructor with the keyword this, and I will pass it the width. Now what this passes is it takes this width variable and passes it. So it's being received here, but it's passing it here. And now I'm going to pass it something for the length. In this case, we don't know what the length is, so I'm just going to pass it 0. So So what we have going on here, even though when you call this constructor, as we do right here, okay, we know that this one calls the overloaded constructor that takes a double, which happens to be this one right here. It'll take that double. That double is a 10.5. That 10.5 will be received in this width, and then takes that variable width and passes it to the constructor that takes 2 parameters. So 10.5 will go from here, double click, it'll go to here. That calls this constructor, where it sets the width field equal to 10.5. The length will then be equal to 0, and it calls calc area. You know calc area multiplies the length times the width. 10.5 times 0 is 0, so you still have to set the length. But what this does, this is a constructor initializer. Again, it eliminates the repetitive code, which I pointed out to you existed, and it says, well, call another constructor instead. So you still have the flexibility over here to create a room that only has a width. You still have that flexibility, but you don't have the repetitive code over here. The end result is essentially the same. You have a room with a width, it doesn't have a length. You're just eliminating repetitive code.
So it just redirects it to the parameterized constructor.
It redirects it to this constructor instead.
The most inclusive or whatever. The one that.
Yeah, unless it's the no-arg one. Now, in the book, even though I don't really see, other than showing you how to do, I said I'll show you twice, right? In the book, they show you you could do it here too as well, right? You could have, okay, let's say, here's the scenario. Let's say you want, the room to have a 1 and 1. So if they call the no arg constructor, maybe you want the room to have a width and a length of 1. So you could do that. Pass 1 and 1. They call the no arg constructor, passes 1 and 1 into the width and the length.
So you don't get zeros anymore?
So you don't have the defaults of zeros.
So that means, so if you were to call...
Or you could call the defaults of zeros here, which is what the book does.
If you were to call one with just one parameter, like a length, then it would go to the one overloaded method that accepts one thing and then redirect it to
Yes.
a parameter one.
That's exactly what this one does. That's exactly what that does. Again, when you see constructor initializers, think reduce, repetitive code in the overloaded methods by using this to call another constructor. That's the benefit, and that's how you do it, and that's how it's done. Now, the last concept here before the end of the video today is the read-only modifier, and this is pretty easy to explain because you have all seen constants before. If I make a private keyword constant integer called, I don't know, costs, right? So we've seen a constant before, and you know that you set the constant when you initialize it. Whoop. See, it doesn't work if you don't initialize cost right away. It doesn't compile. When you have a constant, you have to initialize it with a value right away. And you can't change it, right? We all know that down here, if I try and set cost, that doesn't work. that does, there we go, that doesn't work. So neither of those scenarios worked. They weren't compiling. So when you have a constant, you initialize it right away. Read-only is very similar to a constant in that once it's set, it cannot be changed. But a read-only, and it's a field. And let me, now that I kind of talked about constant, let me introduce the read-only field. Now, not to be confused with the read-only property. Okay, those are different things. Read-only field versus read-only property. Read-only property was a property down here that only had a get block. That's a read-only property. A read-only field is similar to a constant, except you can initialize the value in a constructor or when it's declared. Okay, so a read-only field has a little bit more flexibility than a constant, but once you set it, it can't change. Once you set the value, it cannot change. But you can set the value in 2 places instead of just the one, which is what a constant is. So we might, I might do this read-only field. Again, I'll just use cost as my example. Private read-only is our keyword. Okay, so now we have a field, and notice it can take a value here, very much like a constant. That's fine. But also, you can also set the cost in a constructor when it's read-only. So if this is our constructor, you could set it here. Now, notice that works. That's what read-only, that's how it works. Okay? Where you can't set it, let's say you've got a property and you got a set block. Okay, so you notice you can set a read-only property in a constructor. You can't set it in a mutator. You cannot set it in a property. It won't work. So let's delete that. And that's what a read-only field is. Not to be confused with, although many students do confuse it with a read-only property. Different things. Properties versus fields. Read-only property, read-only field, different things. Okay? So I'm going to stop the video here today. Tomorrow we'll have one more video, and that'll finish up the chapter.